Hi everyone, this is Sai Teja from CSC AML section B. Today my concept is about quantum theory of laser. Let's get into a topic. Today we are learning about the what are the typical components of laser and polarization and saturation and semi-classical theory of laser field and Scully-Lamb master equation and also regression recipe for correlation and also the laser line width and phase diffusion. First of all, what are the typical components of laser? We can identify two types of components in a laser. Some matter that amplifies light called as active medium. Some device that traps the light around the space filled with the medium cavity. In order to obtain an amplifying medium, one has to pump energy into it. The gain medium is thus a converter between the pump energy and the light emission. Quite often, the conversion efficiency is low with values in the range 10 to 50%. Being considered large, the feedback mechanism is needed because the light would otherwise escape from the medium. An optical cavity with a Fabry-Perot resonator, 2 mirrors, does this job because the light can travel back and forth between the mirrors a large number of times. Due to this, the laser will be formed. You can see general ideas. Sargent and Scully in the year of 1972, they proposed the following diagram that relates the different theories needed to describe a laser. We can see the diagram. The two scientists called Sargent and Scully, who proposed a diagram which related the different theories needed to describe a laser. We can see on the screen. The magnetic field drives microscopic dipoles in the laser. This was the topic of the previous term. A statistical description gives implicity in the density matrix approach. We followed links the dipoles to the macroscopic polarization of the medium. The polarization enters the Maxwell equation for the magnetic field as the source and generates the field. In the end, a self-consistent description is required. The fields at the left and right end should be coincide. The following conditions are first one, the laser threshold, the laser intensity to steady state, the laser frequency. With the help of the laser, we can find some of them. We can find the laser frequency. We can see the laser threshold and also the laser intensity in steady state. This can be achieved even when one treats the field written classically. For example, a classical or coherent field appeared via and Rabi frequency in a Bloch equation of the previous term. This approach is called semi-classical laser theory. And also note that nowhere in this approach does the word photon appear. If one is serious, when a quantum mechanical description is adopted, the photon finally comes into play and one may also derive the photon number probability distribution, named as photon statistics, the intensity fluctuations and correlations of laser light, and also the phase fluctuations which related to the laser light wave. Active medium. So the word active medium cavity inside the cavity that provides the polarization consists in many cases of a large number of atoms or molecules. These atoms are prepared in the excited state by the process that feeds energy into them, pumping mechanism, and then wait to release their energy in the form of photons into the cavity field. A two-level approximation for the atoms is a simple way to account for the sharp, nearly monochromatic emission spectrum of a laser. We could have used it as well as harmonic oscillator too. However, this does not reproduce some basic features of the laser like gain saturation. The quantum theory for the atomic light interaction gives us an expression for the microscopic average density dipole HD of T. The polarized field is then simplify the number density of these dipoles called as P of x comma t, that is equal to n of x of h of d into t of y. General, the density n of x is position dependent. In fact, also the induced dipole is because it involves the light field at the position x. The complex, slowly varying polarization field can be connected to the coherences of the density matrix in the rotating frame. We can see the derivation, and also we can see the diagram how the four level model to describe incoherent population pumping in the upper state of the laser transition. We can see through the diagram which was present on the screen. Polarization and saturation. We, we now have to find a way to determine the dipole moment of the two level atoms. Recall that its imaginary part is essential for light amplification. We shall see that it depends on the atomic version population difference between upper and lower state. To this end, we use the optical Bloch equations for the atomic density matrix with some modifications by adding additional energy levels. This mechanism beyond some phenomenology phenomenological rate equations. The modified two-level system is, for example, a four-level atom with fast relaxation in the two upper and two lower states. A simple model with four states as shown in the figure is outlined in the exercises. In this limit, the optical Bloch equation can be simplified and one gets a justification for the often used the rate equations. Semi-classical theory of laser field. We start with a reminder of the electrodynamics in a material with the given polarization. Let us recall that the polarization field enters the following Maxwell equations. 1 by mu naught of delta into B equal to J plus delta 1 by delta J of, sorry, E naught of E plus P, where it is the bound part of the current density. We put it in the following the free current density of J equal to 0 because we assume that the active material is globally neutral and the light only induces dipole on Stirling-Lamb master equation. We are going to learn about the Stirling-Lamb master equation. In this section, we outline the theory of laser that starts from the quantum description of cavity field. We still use for simplicity the single mode approximation. The basic observables are hence. Oh, okay, let's get into topic. The basic observations are hence the manipulation and creation operators A plus for the field mode. The laser is one and open quantum system because energy is continuously fed into the remote from the cavity mode. We have to use a density matrix description as we did the first part of the two-level atom. What are the reservoirs that the field mode is coupled to? First of all, the mode quantum outside the cavity, a part of cavity loses show up here and permit to observe the laser dynamics. But in general, losses also occurred in the material that makes up the cavity mirrors and optical elements. Finally, the laser medium is also a reservoir of energy that may flow into the field mode or not when the medium spontaneously emits photons into other modes. Photon statistics. To start our analysis, let us compute the rate equation for the populations P of n to Nn, finding n photons in the cavity mode. The sum of damping and gain gives the master equation. We are cheating with the photon under photon number in G of A of t. As the trace is no longer considered, we can see the photon statistics derivation, how it was derived and how it was used in the laser. Regression recipe for correlations. We know how we now have to find an expression for the phase diffusion coefficient. To this end, we shall derive an equation similar to the diffusion equation of 2.47 centimeter. Since this equation deals with the distribution function for the phase, it seems natural to reuse the equation of motion for the phase probability distribution for the laser amplitude that we found in second 2.6. Let us recall the steady state solution of 2.45 seconds of this equation. It does not depend on the phase but only on the modules R of the laser amplitude. We can see the regression recipe of correlations derivation and how it was uh, derived in the laser and how it was modified in the laser and how it was involved in the laser. We can see the derivation. Micromeasure model. The operation 2.60 describes an elementary pumping event of the laser. We assume in the following that this event provides only a small change in the density operator. M of minus 1 is a small to provide a more realistic description. One introduced the following addition averages. Excited atoms appeared in the laser cavity at the rate R such that R2 R of minus 1. Over a time interval T, a number of RT pumping events happens and the accumulated change is the density operator is up to R of T of m minus 1. This will lead us to a differential equation when T is small enough. Micromeasure model. The quantum theory of a laser is a text example of a nonlinear problem that requires techniques from open quantum systems. The key issue is a non-linearity in the gain of laser medium due to saturation that leads to coupled nonlinear equations. Already at the semi-classical level, the quantum theory makes things worse by its use of non-commutating operators. Recall that in the called as semi-classical theory, the following equation of motion for the intensity to the laser mode can be derived. Laser line width and phase diffusion, laser line width and phase diffusion. The spectrum of the laser is related to the autocorrelation function of a laser mode operator A. We can see the derivation laser line width and phase diffusion derivation. The spectrum of laser is related to the autocorrelation function of the laser mode operator A, where the average is taken in the stationary state that is reached at large times. We shall denote the state as by the subscript H is if the mode were evolving freely at the laser frequency. Polarization and saturation. We now have to find a way to determine the dipole moment of the two level atoms. Recall that is imaginary part of essential for light amplification. We shall see that it depends on the atomic inversion known as population difference between upper and lower state. To this end, we use the optical approach equation for the atomic density matrix with some modifications by adding additional energy levels. This model also provides a better understanding of the pumping mechanism. Beyond some phenomenological rate equations, the modified two-level system is, for example, a four-level atom with fast relaxation in the two upper and two lower states. A simple model with four states as shown in the figure is outlined in the exercises. In this limit, the optical Bloch equation can be simplified and one gets a justification for the often used rate reactions. Semi-classical theory of laser field. We start with a reminder of electrodynamics in the material with a given polarization. Let us recall that the polarization field enters the following Maxwell equation. Here is the Maxwell equation and how it was involved in the polarization field and which enters in the semi-classical theory of laser field, where it gives the bound part of the current density. We put in the following the free current density J of equal to 0 because we assume that the active material is globally neutral and light only induces dipoles in it. You can see the micromaser model operation of describes the elementary pumping event of a laser. We assume in the following that this event provides only a small change in the density operator. You can see some of them. The quantum theory make things worse by its use of non-communicating commuting operators. Recall is also called a semi-classical theory. You can see the laser line width and phase diffusion. The spectrum of laser is related to the autocorrelation function in a laser mode operator of A. The derivation which is involved laser line width and phase diffusion, which explains the correlate related to the autocorrelation function of a laser operator, where the average is taken in the stationary state that is reached at the large times. We shall donate the state as by the subscript if the mode were evolving freely at the laser frequency. We can see the laser line with how the spectrum of laser is related to the autocorrelation function of a laser operator. In the average is taken in the stationary state and reached at large times. We shall donate the state if the mode were evolving freely at the laser frequency. We can see the derivation, how it was derived and related to the autocorrelation function of S of omega equal to limit t tends to infinity. Thank you.